Okay, let's talk design. Okay, so here's the top. So this would be going up, as you'd be looking at the panel going up. This is towards the ceiling. Let's start over here and just walk through this. This is just kind of my wiring diagram. It's not a schematic diagram. It'd probably be better to show a schematic diagram, but I'm just kind of talking about like the parts and how to put together the parts sort of at a high level. So let's start here with the Pi power supply. So the Pi power supply comes in here into this opening into the box. Power comes into the Pi 3B. So we got the power coming in on the power port. Separate power for the Pi. And here's the pin headers right here. And this is where we're going to connect everything into the security system. So let's start with the MCP 23017. That's the expansion board. The expansion board is because I have 15 sensors, and you don't have that many GPIO pins on the Pi that you can use. Plus, it just gives me generally better control of everything. And I don't have to use as many wires going into these pins, as you'll see in another video when I have to show you how this is hooked up. But basically, it's a 3.3 volt board coming into power here. You connect up the SCL, the SDA, and also the ground. I'm not showing it here. So this has an A side and a B side channel for the pins. And this is where the input values for the sensors are going to come into. And they're at 8. So, and they're actually marked 0 to 7 and 0 to 7. And that's 8 total on either side. So I have 16 sensors. I'm going to hook them in 15. So basically, so that's what's the 3.3 volts coming into here. And then, so these outputs, and I guess I should show like the outputs from these are going to hook into here. So this is out signal from the optocoupler, and we'll cover that in just a little bit. So that comes in right here. All right, so then I have a 5 volt to 3.3 volt power regulator. It's basically a power boost because I don't know if I can power everything from this 3.3 volt. All these optocoupler boards with the 3.3 volts because there's not many milliamps coming out of that 3.3. So what we do is we take the 5 volt pin off the Pi and boost it to a 3.3 power, and that can give us up to like 800 milliamps. At least the board, the one that I'm using, the power regulator I'm using, goes up to 800 milliamps, and that should be way more than what we need. Anyways, so then 3.3 volts comes out of here. So basically, everything I'm working on is 3.3 volt with the Pi. That's key. The only 5 volt stuff I'm doing here is just tapping in the 5 volt power and giving a power boost and regulating it to 3.3 volts out. Those come into these optocoupler boards, and there's 4 of them. Just the ones that I got, just because they have 4 ports on each of them, so that gives me 16. So now I can plug up 16 outputs from these up into this one, which is 16, right? 8 and 8. So that's why I have 4 of these here. So you got 3.3 volt coming in, you have ground coming in, and ground is tagged. I have them basically pigtailed, not pigtailed, but like daisy chained into each of these to the ground, which goes back to the ground pin on the Pi. And basically on the 3.3 volts, I tied everything back to ground pins on here. And this actually has a ground pin too. I just didn't show it all because there's a lot of wires for this expansion board. I'm just assuming ground is connected up to everything. Anyways, so let's go back to these optocoupler boards. So these 3.3s have a 3.3 volt in and a ground, and they also have outputs like I just showed here. The output comes out to the expansion board into these pins, and these are what the Pi picks up. These are the values that the Pi picks up and acts upon those input signals. All right, so basically this is just repeating, nothing new here. So these are 12 volt to 3.3 volt optocoupler boards. And this isolates the 12 volt signal from getting back up into the Pi and burning the Pi. Very important. So I got 3.3 volt here. So I'm got 12.3 volt circuit separated from the 3.3 volt circuit. So now let's talk about the 12 volt circuit. So the 12 volt circuit is just a 12 volt, 1 amp power. I got hooked them to the outlet, and it's an adapter of AC to DC. And I should put DC here, I guess. It's kind of important. So DC power. So you have it goes on split into a positive and a minus. Again, the minus I'm going to use as ground as common. That's going to be the common one going into these boards. And the positive I'm going to split into two circuits with a 5 amp, a half amp fuse on each of them. So these both have 2 half amp fuses on them. So one half amp fuse is covering this one, and another half amp fuse is covering these two. So 2 optocouplers with one circuit 5 amp, and then another, half amp, 500 milliamp, and 2 optocouplers with a 500 milliamp fuse too. So that should give us enough power to both run these boards and then also run the sensors. So the sensors then come in and are hooked up into these ports, into these optocoupler ports. And these optocoupler ports will pick up the signals from the sensors. And how we connect up those sensors is we basically are going to need to take the red wire and have a resistor. So that's probably not the best. Okay, so the red is just going to hook into the power. So the red is just going to hook straight into the positive that's coming out of this adapter here. The red wire is just going to hook in directly to these power. And I have a power block. That's how I'm going to connect it, is a power block. And basically it's just splitting it off parallel. So that power is going to get split parallel into each of these wires, gets hooked into a port of those, basically a parallel line of those. And then the black are just going to hook into these positive of the optocoupler boards, and you'll see that. And the negative I have hooked up as minus into the minus part, which is the common. All right, so there are going to be black wires with a resistor, and here's the resistor. So you have the black wire coming in here with the resistor going into the port. And that is it, totally, at a high level. Probably doesn't make a whole lot of sense right now until we look at the hardware. So let's take a look at the inventory list and the hardware we're going to use for this. All right, let's do a real quick rundown of physically what this looks like. So here's the Pi. Here's the MCP 23017 expansion board that's hooked up to these wires up to the I2C ports on the Pi and the 3.3 volt and ground of the Pi. This is the 3.3 volt power regulator. This is connecting into the 5 volt of the Pi, and this will give us more power. We need that power to supply power to this side of the board to power these LEDs on this board, and then that'll drive our input signal into this expansion port, which you can see I have 2 sensors, 2 inputs coming in here on this channel A, and here's channel B. I don't have anything hooked up there right now. I just have these 2 inputs hooked up right now, which are hooked up to this sensor at the moment, and then this one is another sensor coming in. But anyway, now let's look at the 12 volt side. So that's a 3.3 volt side. This is our 12 volt side. So basically the ground, common, minus, pole, I just daisy chained in here with all these little wires going into the negative. And you can see 1 minus, 2 minus, 3 minus, 4 minus, and so on and so forth, right? And then the really cool thing, the really nice thing about this that I really like is these power blocks. These power blocks are really nice. So this allows me to run the positive in parallel. So this is parallel, putting everything into parallel here. So now, here's an example. So I'm running parallel into here, onto the second block. This allows me to plug in power to this sensor right there. And then I just input. I was testing the last one on here. I wanted to make sure that the last one, basically this whole line of wiring works. So I tapped on the last one over here. And that wire is going in over here in this last one, this 4 positive. And that's how it's hooked up. And then I have these half amp, 500 milliamp fuses, inline fuses. Okay, what we're going to need is wire, 22 gauge wire strippers, inline, 22 gauge inline fuse holder with the fuses, small screwdriver set, flathead and Phillips screwdriver. You're going to need nuts to mount, or screws and nuts to mount these boards onto the board. The pi is M2.5 size. These are 2.5 as well. These are all 2.5. This one is a 2. These holes down here are itty bitty. They're M2s. And then these power blocks work well with M3s. So M2s, M2.5, and M3s are all going to be the size of holes that we'll need to mount these onto the board. Then the other things you'll need is the pi, the expansion board, the power regulator, the optocouplers, 4 of them for 16 total inputs, and power blocks, and then power supplies. So this is a power supply splitter for the 12 volt DC adapter, and then I have a power supply for the pi. So 2 power supplies, and that is the basic requirement of parts that you'll need. There could totally be a lot more. This is just covering the absolutes, but there's going to be a lot of little parts, pieces here and there, you know, that you have to fit in as in addition to that. I'm just covering the main parts.